Hi there, this is Darren from Better Buildings, and within this course we're going to jump into a bit of geometry, a bit like what you can see on the screen. In fact, this is exactly the model that we're going to be using, and this is exactly the expectations that we're setting at the start of this course to be able to model, and you're going to be able to do this yourself very, very soon. I imagine this session is going to take at least an hour to go through, and what we're going to do is we're going to assume that you've had some exposure to the geometry residential course, and the reason is that there's going to be a lot of duplication in terms of content. So please go ahead and have a look at the geometry course, and that's particularly related to the drawings, how you draw a zone, how you distribute zones, how you specify zones, how you attach spaces, how you look at shading and renewables, and ultimately generate a building's form. Within this session, we're going to take it slightly different angle, because we want you to be able to effectively do more advanced features which are more in line with some commercial buildings. So here we go, let's jump in and have a look. Again, unlike the previous course for geometry and residential, where I went ahead and created the geometry, this session is going to jump into a model that's already been pulled up by myself. And this model, to be clear, is to be used for all other courses related to commercial buildings. So whether it's carbon, whether it's daylight, or whether it's HVAC, we're going to be using a model like this. So you're free to request this model, but you should be in a position at the end of this course to go ahead and create something similar to this, so you can then use that course. So what I would recommend is that you create a project when you do, and you create a project called Better Building Training or something like that, that aligns to the commercial side of your deliverables, and then you go ahead and reuse that for all the courses, because I'm going to be reusing this model extensively in order to familiarize ourselves with all the features across the platform. Now, this model happens to be based in Brisbane, and this model happens to be, well, it started as a two-story building. It's more than that now. I think it's about 4 stories, 3,400 millimeters in floor-to-floor height, and it's actually tethered to 9B, and of course climate zone too, because we're in Brisbane. Now, that would be obviously different if you were in New Zealand, or different if you were in a designer mode, because you would be nominating those as your workflows, but we just happen to nominate the National Construction Code in Australia. It doesn't make any difference to the content of the course. It's just a decision that was made. So we're going to jump into the course here, or at least the design, and we called that design concept. And here is a look at the design. There's a lot going on. So in terms of trying to go ahead and I guess do all of this in front of you, the course would end up being a few hours long, because there is lots of zones involved and lots of specifications involved. Again, please go back to the geometry residential course in order to get some additional drawing information. I will spend a few minutes just to re-familiarize yourself with what drawing is about in terms of adding zones and editing zones and splitting zones. So I will go through that, but it's only going to be for a short amount of time, because there is a dependence on that geometry residential course that is there to provide that learning. So okay, so now we're in here, we have a bunch of zones. All of these are deemed to be thermal zones, independent zones that can be controlled from an internal load perspective independently, subject to how the building has been set up. I'm going to turn off some information there, the tags. just because I don't want too much information on the screen at one time. The model has been set up as a ground level, and I have additional levels within the model. And these drawings here, we have ground, we have void, and this here is effectively a zone that's been pulled together to create a complete void and to create a additional space here that has been merged with the space or the zone below. That'll make more sense in a wee bit. We have our first and second floors. These are exactly the same as they go up the building. And then we have a paired back, I guess, third floor upper level here. Okay, so we're reusing, in this particular model, we're reusing the ground floor model for the benefit of making sense of the overall building, but also it is quite typical to do that. And what we've effectively done is we've gone ahead and used these tools up here to draw this space. So let's go ahead and redraw a few spaces in the model. How about that wet room to start with? So the process that I'm about to show you here is rinse and repeat for every single zone. So we have a wet room that we want to draw. We can identify add zones here. And then we can draw this in here. And I'm just going to draw in a square, and call that wet rooms. It's actually wet room, and I'm going to pop on training there. And you can see that's where you can go ahead and adjust the name should you make that area yourself. Now, once we've got the shape, we can grab the nodes and pull those around by left clicking the node and dragging it. You can also go ahead and hold down shift, and then you can add additional nodes onto your zone. I'm just left clicking and shift, and then if you hold down control, all your nodes will turn red and you can go ahead and delete some. So this is effectively what you'll use throughout. Those shortcuts are available there, so go ahead and have a look at those in the pop-up drop down. And now we're just going to go ahead and connect this zone to the model. Okay, so nice and easy. Go ahead and connect it to the model, and that's that. Now what we always do, well, what I encourage people to do is always to draw in the width of the windows as they appear. So I'm holding down shift here again, and I'm just going to drop that in over here, and then I'm going to drag this to that point there. What I'm also going to do is I'm going to hold down shift so it snaps to the X and Y axis, so we make sure that we have nice straight lines as we do so. Hit save, and that there is our first drawn zone. So that process is effectively being repeated time and time again throughout the model. Okay, so it is something you'll become very familiar with, and that process is normally 60% of the work in the modeling space. It's a significant chunk of the work, and I've gone ahead and I'm going to make a bit more room here. I've gone ahead and done that for everything here, each of the zones. You may or may not need to do it in as much detail as this, or you may choose to do it in more detail by adding on perimeter zones in glazed areas should you be going through more advanced workflows such as Green Star, LEED, neighbors, etc. Once you've drawn a zone, you want to add information to that zone. So that information could be glazing, it could be an internal door. So let's go ahead and add all of those in here now. Now first of all, let's grab a window. So we're going to pop on a window, and I'm going to reveal something here called tags. Now I turned those off there because I didn't want to confuse everything, but I do want to make sure that we're very, very familiar with what tagging is. Again, covered in the Geometry Residential course, so please go ahead and jump into the details there. But effectively what I've done here is I've used tagging. If you navigate to Manage Tags, you'll see tags that have been created across the platform. Okay, so all of these tags have been created and they have been distributed to the model. So what do I mean by that? So let's go ahead and see this here. Punch window has a purple triangle. You see the purple triangle there? That's telling us it's a punched window. We also have another tag on the window, which is the blue square. What is that? Well, we can go back here. Happens to be shading. We'll go through the details in a bit. But what we want to do now, with the window that we updated, we want to bring those tags back in here. How do you do it? It's very, very simple. Go to Tag, select the aspect, and you can select multiple aspects in many ways. The shortcuts are there presented for you, so you can just left click, or you can hold down left click and drag to make box selections of aspects. So left click and drag. See, that's a box selection. Or you can just select the outer side, or you can even go ahead and select all the zones by holding down Control and dragging. So there's many different ways to do this. But now I've selected that, and I'm just going to hit Enter, and then I'm going to add on the punch window tag and the shading tag. Apply those, hit Save. So it hasn't done anything yet. We don't have a visual nomination of glazing, such as in this case, because we haven't actually added the glazing. We've only added the tag that carries the specification for the glazing, but we've yet to add it. So how do we add the glazing? Well, I'm going to show you how you should be using the tagging system wherever possible. You're going to go to a window, and you're going to copy the specification of this window in terms of its geometry to here. Okay, so how do you do it? Left click, go ahead, navigate to Save and Copy to. So you're just effectively copying it over. So if you go over to punch window, and what you can do is that you can actually navigate through, or you can select all, but I'm going to navigate through, and I can see here that there is an external aspect that has no window. So I know that that is the window we're talking about, and I'm going to copy over both window and shading to here. So what that means is that when I go ahead and select, I can see the window placement is as per the other window placements. Okay. So let's go ahead and have a quick look at some of the complexities around this tagging. Just to finish up a final point on tagging, you know, it's used for glazing systems, shading systems. It's actually used for full-on space and HVAC configuration. So its distribution in your workflow is fundamental and will save you serious amounts of time. The amount of time I see people going around and clicking individual things, whether it's an aspect, whether it's trying to nominate a floor or a wall or a roof system or even spaces, and it ends up just being a very complex process that fundamentally does all the exact same things that I'm outlining here. Okay, so tagging is really important, and once you have tagged an element, you've given it a name. I'll go ahead and add one here quickly. One tag, or what title, example, let's say example. Hit enter. This then needs to be distributed, and it needs a specification attached to it. So you'll see at the moment where we've got shading here, space, wall. That's telling us that there's a specification set elsewhere connected to this tag. So if we go to curtain wall, for example, I'm going to go to Windows, save that first, go to Windows. We can then see curtain wall, so we can see that we have nominations here. If we go back to the tag, we can now see window. If we go to example here, and I'll pop this up as an example. Let's say we have a wall, and we want to find that example, and we want to nominate specifications to the example. That's all you need to do, and then you can change and save, and update other attributes such as thickness, density, and heat capacity. But when you go back to tag now, you can now see that the wall has now been nominated. Of course, this isn't intended to do anything, so I'm just going to go ahead and delete that, but I'll have to go back to walls first, remove it from here, click save, back to tag, and now I can delete it. Fundamental. The other tag that we have in play here is an office space. So I want to spend a little bit of time looking at the office space. We can see we have two offices here, and I'm just going to use this feature here to nominate the offices here and here. What we're saying here is that the whole building is using a 9B, which is like a school. It's a building class in the National Construction Code. And this could be ASHRAE, it could be the New Zealand Code, it could be a Green Star building class, it could be a number of things. But we've got this nominated here. If I go back here, we see it here. And then if I go to our spaces, I can also see it here. So let's go ahead and reconnect that so we can see exactly what's happening there. I've nominated those zones. They are offices. So instead of using the default space, which we have as a 9B, we're going to go ahead and grab the tag, and we're going to say that they happen to be office spaces. And then we're going to connect the tag. Before I do so, I just want to make one point here. We're only seeing a bunch of templates pertaining to the Australian code because we are in an Australian workflow. But if you are in an international workflow, you're going to see ASHRAE. If you're in New Zealand, you're going to see New Zealand templates. This is how to complete the process. And once you save that there, all occupancy, lighting, equipment, infiltration, thermostat settings, humidistat if they were there, sizing, HVAC, purpose, and building class, they're all set. Okay, they are all set. So click save. So now we have our default space, which happens to be the 9B, and we can see that under here. Default space, and then we have the office space. Okay, pretty simple stuff. Let's go into some more complex stuff. So we have distributed the tags for walls. We have a brick veneer wall and a rain screen system. These have just been distributed across the model in order to represent them, and we'll see how they manifest themselves in a report in a later session. We won't be running simulations in this session. We're only focused on distributing information and creating geometry. We're using the default, so all roof systems identified are using default. We have not nominated any additional roof systems at this point in time. Floors are all nominated with the specifications here. We have not changed anything, haven't nominated anything. Window systems, we have 4. We have our default, curtain wall, window wall, and punched windows. In fact, it's probably true to say that we have 3 because the curtain wall, the window wall, and the punch windows comprise the entirety of all windows in the geometry, and therefore the default window is not actually being used. If there is a skylight, we're going to default to the specification for the skylight. If there are glazed doors, we're going to default to these. Opaque doors, which I believe we do have opaque doors, so we can add in some defaults for those should we want, and we've also got some shading. Okay, and I'll show you a little bit about shading very soon. So as we've and we've drawn around and we've created zones, and then we've added another space and called that another zone, we've gone ahead and effectively nominated all the zones that we can see over here on the left hand side. So all nicely detailed, and this detail matters because when you go ahead and create a level of detail like this, all this comes through to your reporting. So it makes it very, very easy to see where you have challenges in your model. So it's pretty fundamental. And one day, not too far away, we're going to be in a position where all of this is effectively automated directly from a report or from the drawings, because I can't imagine that won't be automatable very soon. Okay, so lots of information in here. So let's go ahead and turn a few things off, or rather delete those zones there, and let's have a little look at the model itself again. So the model itself is distributed as a ground floor, a void, which is on top of the ground floor. The ground floor is 3,400 high. The void is only a meter, or 1,000 mil. 3,400 for the first and second floors, and the third floor is, guess what, 3,400. And all of these combine via levels. So it's effectively comprising 5 levels in total. We have level 1, level 2, level 3 and 4, and level 5. And that allows us to generate something like this. Now, let's go and explain detail in the model and where it is. So starting off on the ground level, we have a little bit of detail here. We've got this canopy here. We've got some shading, static shading devices, or they're all the same, these shading devices. We've got a window wall system, and one thing that may not be super clear here, if we go ahead and turn off the external wall and the vertical glazing, what you can't see is that actually this volume here is 2 volumes combined into one. Okay, so you can see this level here, this very small level. It's not for very small people, it's a void. Okay, but over here we have combined into one level, so we'll be having a look at that. We also have another space over here where effectively it's a full height space for the height of the building. So there is detail here. Let's go and have a look at, we'll look at the voids to start with. and then come back to the shading. So this void here, and I'll try and zoom in here a little bit. The corner here is that corner there. And this space here is just a space that is 3400 high. And what I wanted to do was generate another additional height of 1000 millimeters. The question is, well, how to do that? Because in the drawing space, everything that you draw is the same height. So how do we generate a variation in this space here that is not in these spaces here? Well, the answer is we go ahead and use the duplicate function here to create an identical drawing, and I can go ahead and do that. Duplicate. And then effectively what we're doing here is we're saying, okay, well, do you know, we want to create an additional void here through this duplication. So we're going to go ahead and remove this 3400 and pop in 1000. So that then becomes just 1000 mil high, the whole thing. And then there's all these zones within this void, and this is all an unconditioned void. This is the only bit that's going to be conditioned. All of this is unconditioned. So effectively we go ahead and delete all of that and create one. Now I'm going to quickly show you how to do that because it's very quick to do. So I'm deleting all of these, and we're going to just create one. Here we go. How do we do it? Well, we use a feature up here called layers, and we're just going to turn on the ground level here, and then we can see the ground level. And once we can see the ground level, we can then go ahead and draw in these zones. I'm not going to complete it in any level of detail, but you get exactly what I'm doing here. So I'm just bringing this in and calling it a void, and then setting up the model like that, which is effectively what I've set up over here. So that is exactly the same as what I've set up over here. The big, I guess, thing here is that this is completely going to be a unconditioned space. This is above the ceiling line, and therefore is not a conditioned space in this model. And then when I go over to the zone that is conditioned, we simply apply an internal floor, and this is where we apply it. We apply it here. So if I were to get rid of that, hit save, we go and regenerate. It's giving me an error now because I've caused an error by removing that because of a impact on window height. So I'm going to go ahead and put that back. But the point I was going to make there, it's probably, what have I done? 2 seconds. Let me see if I can find this quickly. Didn't expect to see that error. Oh, it was just that. It was just the other drawing that was in there. So now that's disappeared. Just to reiterate, we brought in that air floor, and by virtue of bringing that air floor in, we've removed the ceiling that was separating this space here and this space here. The exact same is true for this void here. This is the void that is continuous up the entire building. And what we have in this case is that we have the nomination of air boundary set at each level. So it's all set up at each level, and now that it is, it means that we are going to connect up all of those levels. So that's it. That's how you combine spaces into one. Now, while I'm No, I'm going to come back to the subject of that later on. I'm going to go back into our model and identify a few more things that have gone on. So over here we've got some shading. Okay, so this is all drawn in 2D, and you may have shading devices that are much more complex than this. We're going to adjust these now. I'm going to show you how to do that. This shading has been distributed using tagging. Okay, so what that means is that that square there, the blue square, is represented by a tag. And once it's represented by a tag, it's then specified by the same tag. And this happens to be specified as a top surface projecting out. That's the top surface projecting out from there to there. The left is projecting out, starting at 0.5 and tapering down to 0.5. Okay, so this can all be changed, of course. It has a dual projection, so the top is 0.5, 0.55, 0.05. These are easily resolved. We'll go through some examples in a second, really quick examples. And then the right is the same. So let's do something very quick. So let's go ahead and first of all say, okay, this is a single projection, the left and the right. I'm going to save that now and regenerate the DXF. What that means is that lower projection has now converted into a single projection, so the 0.05 is gone, and we now have just a single projection. Not as funky, but it's a single projection. Should we want to go ahead and use things like gaps? So that's the gap from the facade line, and I'm going to just do that in both. Just going to put in a gap there, and you can go ahead and do, offer in some rotation should you want. There's many things you can do. You can offset, you can shift shift it to the left or to the right, or shift it left, shift it to shift it down, shift it up, and set opacity. So there's a lot of things you can do. Just going to save this one here, so I'm just going to offset that. Really simple, easy. There will be a detailed shading course available, so I'm not going to spend too much longer on this, but we will go ahead and update this to be significantly different than the one that I had in the model. So you can see that that's now shifted off there. I didn't shift off the head, so maybe I'll just kind of close that out there and add a gap there like that. And you could settle with that, or you could go ahead and do something where you had maybe horizontal shading in front of it. So remember, this is a tag that's been distributed, so this is all going to this is happening everywhere in your model. Now when we have horizontal, let's go ahead and see what would happen. So if we go ahead and add a horizontal shading, and this is a repeated horizontal shading with a single projection, and we're going to distribute it as a count. Okay, distribute it as a count of 4 and click save. Let's go ahead and see what the result is there. So this is repeat horizontal shading distributed with a count of 4, and it's been projected out at 0.4. That's pretty funky. Okay, so probably the thing that we probably wouldn't want to do there is project it out, because what we wouldn't want to do is add the gap. So if we just keep that at 0.5 there, and we can then go ahead and save that, and then that would be a a little bit more reasonable, what I'll probably do as well is I'll probably bring this down to, let's say, 2, for example, and click Save. Regenerate. And that's how you use tagging for shading to distribute it across your model. A note, this will increase the complexity of the model quite significantly. Now that's been brought in. So please expect results to take much longer. Given this is going to be a part of additional models, I'm going to reduce this back, and I'm not going to step back through the process. I'm going to use our feature up here, which is View Revisions, and I'm going to make an estimate that I started undertaking those revisions. I don't know, let's say 526 there, and I'm going to go back down to the shading and see what was nominated here. And this seems to be the shading that I had originally. Now that's the case, we can kind of move on to some of the other elements within the design. And that is the case. So you've learned how to access revisions there, and all your revisions are saved. You can also rename the project and make the latest should you need to. Okay, so that's a bit about the shading there. So these we've got voids included, some shading there. We've got, of course, got additional shading elsewhere. Let's stay on the ground level. We also have internal doors. That yellow door there is an internal door. It's been applied locally at the aspect. Just like this. Select door as default. Door placement. I'm going to put this door at 2 meters wide. Click edit, and then I'm going to drag this yellow into position here. Save and close. Why is that important? Well, it's important because if you're going to use airflow network models or advanced models, you're going to want to nominate doors in your model, because those doors can be deemed to be open or closed, and this indeed this doesn't necessarily need to be a door. This could almost be an opening. So if you had some sort of a permanent opening, then you could adjust this to be a permanent opening. Okay, so I think that takes us from the ground to the void. I'm going to come back and we're going to look at all the shading all at once. So we've got this covered. We don't actually have any more content to cover here in the first and second that I haven't covered already, talking to the ground level. The third level is effectively a duplication of the first and second, using the duplication function here. And then I've gone ahead and added in glazing here and here and around here as well to create this, I guess, functional space at the top. So we're just going to use this flat roof as a functional space, and we've gone ahead and added on some shading and some balustrades there. But again, nothing else to really learn about from a geometry perspective here. So I'm going to save. I'm going to get rid of that ground test there. We don't need that anymore. And we're going to look at some of the other elements. So first of all, where does all this shading come from? Well, shading can come from multiple places. As I've already shown, you can distribute shading at a window or door. You can also distribute shading at an aspect, and you can pop them onto your model via the tagging system. You may not want to do this in some cases. You may want to have more control over the shading. You may want to distribute shading at the levels or shading at the site level. So I'm going to show you the shading at the site level next, and here it is. So it looks, I guess, somewhat childish in terms of what it seems to represent here. I'm going to show you effectively it over here on the right hand side that all the orange there is what's been represented by these shading elements here. So to start off with, this green one here is this one here. And what can we see? Well, this is just a shape. It's an extruded shape with a roof design on top. So if we go ahead and go to the shape itself, just navigate to reveal the details, and we'll see that this is the shape over here. If we left click, we can see that the shape is an extrusion with a base height of 0, so that's the ground floor plane. The extrusion height is 12, so should we want to go ahead and change that, I'm going to change that to 2. Save, regenerate, you'll see exactly what happens. It drops down to an extrusion of 2 and will no longer have any impact on the adjacent building. There it is there. Let's be sensible, we're going to put that back to 12. And then we're just going to look at how the surface has been nominated. So the surfaces of the shading, in terms of their control, is very, very similar to the roof systems, where surface types and the pitches can be nominated in order to render the adjacent building. So pretty simple. And that is true for this building here, this building here, this building here, and this building here. Just doesn't happen to have a roof on it. Okay, but we've got some other shading elements. Let's go to this one here. So this road here is meant to be a road. Just a shading element. It's just there for context. There it is there. I'm going to go ahead and change the color of it to red. It's a surface. It's been extruded 0.1, that's it. Done deal. We have the balustrades here, and these have been distributed using the drawing tool. So we have drawn these using the vertical shading drawing component, where you effectively draw shapes like this, give them a name, and distribute them with some assumptions around their height and other details. So let's go ahead and grab that one, name. It defaults to a base height of 10, sorry, a base height of 0, a screen height of 10, so sitting on the ground, screen height of 10, and opacity of 100. These have to be drawn singly at the moment, but that's likely to change moving forward. And that's exactly what's happened for all of this balustrade here. It's all exactly the same. So let's go ahead and have a look at how it's been specified. I can select any one because they're all the same. It's just 1.2 meters screen height. It happens to be 11.2 meters off the ground because it is at this height here, and it's been set with an opacity of 20%. Once the first one was created, the process was effectively duplicate, and the duplicate was then moved as such into the next position. And that is the best way to deal with repeating shading elements that have the same specifications. So I'm going to pop that back into place. And that's that shading. We've got quite an elaborate kind of pergola type structure here, which again is just extrusions. So nothing too crazy about it, but effectively this here has been drawn, extruded, and duplicated and repeated. This has been drawn, extruded, and duplicated, as has this, in order to go ahead and generate this pergola structure, which I think are really great in peak summer. So there you go. Now we have one other element here that's in the scene, if you like, and this is kind of like a tree. Okay, so let's pretend that there, the green there is the trunk of the tree, and we have these elements here that have a screen height of 10. They have a base height of 4, so that's the underside of the canopy, and have an opacity as well. They're using the offset feature here, which allows the creation of triangular or trapezoidal shading, and effectively we've offset by 50%. And once we've done that, I'm going to go ahead and regenerate that because I changed the size of the trunk. It's given us a shape based on the distance between here and here being 50% in the offset. So if I go ahead and look at this, so it's a bit slow. We'll see that that is 50% of that width there, and it looks a little bit like a tree. Completely up to you how you model this. So there's a lot that can be done in terms of shading, but it's not the only place that shading has been distributed. So we've now seen two spaces. We've seen it at the site level, quite elaborate, quite time consuming. We've seen it at the via tagging, which is very, very, very efficient. And you can also have it at levels as well. So in the levels, if you navigate to your levels, we've got shading here too. Left click, we can edit. And effectively what we have here is shading that's been applied with an overlay of the ground to form a canopy. So this is effectively been, guess what, drawn using shading. And then we've set it at a base height of 3.2, knowing that the height of the floor to floor is 3.4. We've extruded it 0.2. And we haven't set any opacity to it at all. That's formed that shape for us, and that creates a meaningful canopy down at the reception level of the building. So there's quite a few little tricks going on here. Next, let's jump into roofs. And the reason we're jumping into roofs at this point is because we can see roofs are distributed at the levels. So each level can have a roof distributed to it, and that may be true if you have levels popping out of the building. We don't, so we're going to go ahead and just distribute it at the top level here. So if I left click, edit roof, we can see a roof. If I go ahead and put on the levels below, we can see that I've effectively just drawn a roof around the level below. And to be uber clear, it is effectively that roof there. What we're going to do is we're going to change that roof now and redraw it, because roofs are pretty tricky and probably warrant a complete session on their own. That's the roof gone. Let's go ahead and add on a roof. Okay, so typically you want to go ahead and connect to every node. And I say typically, and that's if you're not drawing straight and you're not being really cautious about your drawing. Then if you do not connect to each node, please expect to have issues. Now, because I'm somewhat of an advanced modeler, I don't need to do that because I know everything is nice and straight. But if you do have problems, connect to each node until you're confident that you don't need to, and it's not going to cause any errors. Now, I think I know there's going to be one error here, so I'm going to go ahead, pop on roof, and see that there, that red arrow, that was just saying that there's a bit of clash there, and that's now okay. So next we're going to go ahead and go to the roof itself, and we're going to make a selection on its type. So is it a single pitch, double pitch? Is it going to be a hip roof? I'm going to say it's a double pitch. I'm going to offset that roof. Okay, so just offset it a wee bit. Use your keyboard left and right arrows to move sliders up and down. And then I'm going to go ahead and set the pitch. And the pitch is going to be a shallow pitch, 5 degrees. Actually, as an example, I'm just going to leave one at 12 and one at 5. And then I'm going to offset the ridge. You can change the heading should you like. I'm not going to do that. I'm just going to offset the ridge. And I'm going to bring the ridge back to roughly that point there. So I'm seeing that move up and down on the right hand side there. I'm just going to move it to there. Leave it as a cavity, cold roof system. And I'm going to set some pretty crazy eaves distributed across the model. Save and close. Regenerate. And we're going to get our first issue. Now, that was purposeful because I know that there's going to be an issue with this particular space here. And that's because we didn't add nodes everywhere. Now the problem node is this node here, and before I fix that I'll just make a point. The roof above fire pump training, that space there below, on level 5, and to be clear, level 5 is here, must have a point in this location. Okay. You're going to find your coordinates down the bottom there. And if I make my way over here, I'll see that the coordinates are minus 32.7, almost 12. If I drop that there, that's going to allow this space to be completed. And there's a technical reason why that particular space was a challenge, which is something I'll get into in a second. Now that's been created, we are back in business, and this is what our roof system now looks like. So extremely large eaves on there. May not replicate the real world, probably won't. But it is what it is. So let's go ahead and pull that back a bit. We're going a bit crazy. I'm going to go ahead and probably just maybe move those back down to about 0.45, something like that. I'm going to remove the remove it to a single pitch there, and probably might bring that offset back down to 0 just to see what it looks like. Save and close, save, regenerate, and we are now again going to generate a slightly different form of a roof where the ridge is approximately about that line there. Okay, there it is, looking pretty similar to what it was before. but I was kind of happy with that. So there you go, that's the roof. Now, roofs can be complicated. You can have multiple roofs over the building. Okay, so this area here only has one roof, of course, but you could have multiple roofs going in different directions, joining up, so they can be pretty complicated, particularly as you get systems that are kind of like a box cutter type arrangement that is running down the middle of the building, which is often a bad idea, but it's something that we do. Then we can kind of set up a northern roof and a southern roof and slope them towards each other. So there's multiple challenges in roofs, but I'm going to navigate to the reason now why we had that error. The reason we had the error was because we have a particular feature in this model, and it was just in this space here. And if I turn off the roof, we'll see what it is. I've joined the voids to effectively project the insulation line to the roof, and I've just done it in this space here for demonstration purposes only. Now, what does that mean in terms of geometry specification is that on the third level over here, I have gone into my roof settings, gone to ceiling, and instead of having a horizontal ceiling where roof cavities are generated above the zones, I have set a projected ceiling, and that's effectively projecting the insulation to the roof line. Once that happens, we need a perfect arrangement of nodes in the roof to reflect the area or the zone that is being projected. That's purely for geometry, to keep things as tight as possible. So that's the reason why we got the error. And roofs do have complications to them, so please do expect to see a few challenges in that particular space. Now, as I start to wrap up now, I'm just kind of having a look at a few things that I could pop on to the discussion. I'll probably go ahead and just pop on renewables to the discussion because I don't have any here at the moment. So if I go to renewables, what we're actually talking about is PV. So photovoltaics, adding those on, and what I want to do in this case is really just put a very large array on this kind of northern roof, and just going to put them across there like that. Okay, so what was that, 6 meters PV? Let's see. Okay, now I'm going to hit save. I am going to go into the details. I am going to set the tilt to a shallower tilt because of the roof. Obviously the closer you are to the equatorial longitude, longitude or latitude, I forget which one is, I'm getting tired, it will produce a higher system size. So what effectively you're doing here is that you want to be a bit conservative about, the surface coverage. Maybe not the cell efficiency. Cell efficiencies are getting so much better. You can set your azimuth angles, you can set your tilts, you can set your base height to be offset. Let's just offset that for the sake of it. And then you can set multiple rows or a single plane. And if I bring that down to, I'm going to bring that down to, let me see, what was the, actually I'll leave it a large 1.6 there just to see what happens. So I'm going to hit save there, regenerate that there. So that total area of 460 meters squared has been nominated for PV in the model, and now that's there, we can go to the model and see the PV sitting nicely on the roof of the building facing toward the north. Okay, as we should see, that will benefit the design significantly, and you can also obviously spread that all across the roof. So if we're going to be a little more generous with our PV, and why not, we could go ahead and actually just probably just draw a second system on this side. That probably would make a bit more sense. So draw a second system there. I'm a fan, so why not PV2? And I just want to nominate, see what lengths we have on this side here. 6 meters again. So I'm just going to nominate that as 6 meters. And then we're going to keep things pretty similar. 1.2s, or sorry, 1.6s I think I had it at. 0.1s, 80%, something like that. And let's go ahead and see what we can see when we regenerate this now. Okay, so that's now being popped on to the roof there. We need to do a little bit of work on the angles there. Bring up the angles a little bit more. I forget what I popped into this one here, 27.5. This one here. Oh, I put the tilt way back down. Okay, that was a silly move. 27.5. There you go. Done. Okay. So that will generate a meaningful contribution to the building. And yeah, it looks like, you know, there's over 70 kilowatts there of PV on the roof, which should be a great contribution to the building. So there you go, PV on the roof. One last element, and this is jumping around a wee bit, so I apologize for that, is that once we are specifying at the walls, the roofs, the floors, etc., we have the opportunity to do a number of things in terms of how we specify the actual the values that go into from a thermal performance perspective. Now, what you can do is you can specify as a concept, which is the example that I've led with here, or you can specify from a template should you have a supplier that you want to work with, or you could grab a template from Speckle. Oh, that's a bit of a blunder there. And then if you do specify with the template, you can go ahead and give it a name, or you can grab a design that you've created already. So Better Buildings provides the ability to sync with designs that you've worked on elsewhere for other reasons, carbon and condensation, moisture modeling, etc. And should you have developed a total R value or U value for your wall systems, then you can bring those in by just simply identifying them and bringing them in to the design just like that. I'm not going to do that in this case. I'm just going to sit with the default as what I want to do is I want to have a report that shows these nominations here: wall system 1, brick veneer; wall system 2, rain screen. This is the information that I want to see in my report. And should you want to override that here, you either override it at the tag level, or you can actually override it here with a custom title, if that makes more sense to you. Okay, one last little trick before I go, and this is just so you have a model that is set up ready to run, is that when you do set up your model, we haven't really done much in terms of spaces. So we've talked about spaces a little bit. In terms of nominating spaces, you're often going to have, you could have 5, you could have 10 different spaces, depending on how you want to use spaces, depending on how much control you want over lighting and equipment and infiltration and thermostat settings. These will go into these as non-geometric topics in other courses. But should you want to go ahead and make sure that you're syncing everything all up, let's go ahead and make sure you have the basic HVAC system in your model. And I'm just going to clear that schematic there for a second. I'm going to select from a template and select a template, maybe a VRF, and then just make sure that all your spaces are connected to that VRF system. Hit select, and then you can go ahead and nominate some basic inputs for your HVAC system, but this will allow you to go ahead and run a simulation at this point. Okay, that's all I've got for this one. There's plenty of information there. Again, go back to Geometry Residential for items not covered here. I wanted to focus on ensuring that a relatively feature-rich model was an example that was used here, so you could see how it was created. Because seeing how it was created allows you to both replicate it, should you want to, or probably more importantly, bring these features into your own model. So that has been a slightly different way to approach these courses, but I think this makes more sense given how much more information you'll get from this, and to avoid repeating information that is elsewhere. Moving forward, all the additional on-demand course videos are going to be fundamentally shorter because we've spent the time going through fundamentally 2 geometry courses. Hopefully that's given you enough to proceed with confidence, and should you want this model copied over, you're more than welcome to request it. Hit support, hit raise a ticket, and give us your request, and that's all we need, and then we'll pop it into your account for you. That's it. Thanks a million. Thanks for hanging on in there, and don't forget, once you've finished your course, go ahead and publish that certificate once you've passed the 80% pass mark. And if you feel the need, go ahead and promote the fact that you've achieved a outcome on our platform. Any promotion that we can get through that is fantastic. Thanks a million. Bye bye.